So next we have the quotient rule. So we know that the formula in finding the derivatives of a quotient rule is derivative over dx of f of x all over g of x is equal to g of x times f prime of x minus f of x of g prime of x all over g of x squared. So we will now prove this result. To begin, by applying the limit definition of derivatives to a function, which is f of x is equal to limit as h approaches 0 of f x plus h minus f of x all over h. So this would be the limit definition of a function. So we now come up with derivative of dx of f of x over g of x is equal, using this definition, limit of h approaches of 0. So we now f of x plus h over g of x plus h minus f of x over g of x all over h. In the next steps, we will perform two operations. We're gonna combine the fraction in the numerator by obtaining common denominator, dividing by h, multiply the reciprocal of h, which is 1 over h. So we have now limit as h approaches 0 is equal to the reciprocal of h, which is 1 over h, times f of x plus h over g of x plus h times g of x over g of x minus f of x over g of x times g of x plus h all over, not all over, g of x plus h. So we're gonna multiply the numerator f of x plus h by g of x over g of x, this expression, and then in this form naman, we multiply it by g of x plus h over g x plus h. So we have the common denominator. So we will now combine this one and this one. So we have limit as h approaches to 0. So we have g of x, f of x plus h, minus this one, we have f of x and g x plus h all over hg of x g x plus h. So this denominator will be hg of x times g of x plus h. The same with the product rule, we will subtract and add f of x times g of x. So we will subtract and add f of x and g of x in this expression. So we have limit as h approaches to 0 to g of x, f of x plus h, then subtract f of x, g of x, then add plus f of x, g of x, minus the remaining one. So f of x, g of x plus h all over h, g of x, g x plus h. We will now factor out g of x, f of x plus h minus f of x, g of x. So we will now first factor out this and this one also. So we have limit as h approaches to 0, 1 over g of x, g of x plus h. I'm gonna put it ganito. And then g of x, f of x plus h minus f of x. So minus f of x, g of x plus h minus g of x. G of x all over h. So we've left with h here because we factor out this one. We factor out the numerator, so we have here common g of x and this one, so we're left with g of x times f of x plus h minus f of x of this one, and in this expression naman we left with, we factor out f of x because they were common, so we left with g of x then times g of x plus h. But because we have a product here, so we're gonna break up into the difference of two functions. So we have limit as h approaches to 0 of 1 over g of x, g of x plus h times, so the limit of this, limit as h approaches to 0 of g of x, so we have times limit as h approaches to 0, and then we left with f of x plus h minus f of x over h minus, so I'm gonna put this here, minus limit as h approaches to 0 of f of x times limit as h approaches to 0 of g of x plus h minus g of x all over h. So we get we factor out this expression, so we have limit as h approaches to 0 of g of x, so we're left with the limit of f of x plus h minus f of x all over h. So minus here, we factor out here the f of x, so multiplied by the remaining one, which is g of x plus h minus g of x over h. We will now substitute h as 0. So here we will substitute h as 0. So we left with 1 over gx squared, because gx and gx, we have gx squared, multiplied by g of x f prime of x minus f of x g prime of x. So here we come up with f prime of x because that is just the definition, and here f of x. So we left with this one, which is g prime of x, because that is also the definition. So we will now multiply this one and this one. So we have g of x, f prime of x minus f of x times g prime of x all over
the ring
g of x squared. And we are now completed the proof of quotient rule. For example, we want to find the derivatives of 7x plus 4 over x squared plus 5. So our f of x there is equal to 7x plus 4, and the g of x is equal to x squared plus 5. So now what is the f prime of x? So this would be 7, because the derivatives of this one is just 7, because the derivatives of a constant is 0, and this would left with 7. So the derivatives of g of x is we left with 2x. So now we will just substitute this one to this formula. So now we have is equal to x squared plus 5 times 7 minus 7x plus 4 times 2x all over x squared plus 5 squared. So now we have 7 times x squared. We have 7x squared plus 7 times 5 is 35 minus 2x times 7x. We have 14x squared, and then 2x times negative 4, we have negative 8x all over x squared plus 5 raised to the power of 2. We will now combine like terms. So 7x squared minus 14x squared, we left with negative 7x squared, and then minus 8x, and then plus 35 all over x squared plus 5 raised to the power of 2, and we get the final answer. Come to the proof of chain rule of differentiation, which is a rule to find the derivatives of a composite function. So we have here the derivatives of f of g of x with respect to x is equal to f prime of g of x times g prime of x. We have the derivative of a composite function, so this is the composite function, is equal to the derivative of the other function times the derivative of the inner function. So this would be the inner function, and f is the outer function. To begin the proof, we apply the limit definition of derivatives, which is f prime of x is equal to limit as h approaches to 0 of f of x plus h minus f of x all over h. So we will now have the derivatives of f of g of x is equal to limit as h approaches to 0 of f of g plus of g of x plus h minus f of g of x over h. Remember, we obtain h by determining the difference of the innermost, the innermost inputs. So let's make substitution for h. Let's replace with x plus h minus x. So we have now the derivatives of f of g of x is equal to limit as h approaches to 0 of this one, f of g of x plus h minus f of g of x, and let's replace h by the quantity of x plus h minus x. Remember, h would be the horizontal distance between 2 points on the function f of g of x. We will now multiply this fraction by a fraction equal to 1. So we will have the derivatives of f of g of x is equal to limit as h approaches to 0 of f of g of x plus h minus f of g of x over x plus h minus x times g of x plus h minus g of x over g of x plus h minus g of x. So in this proof, we gonna multiply g of x plus h minus g of x over g of x plus h minus g of x, because when we multiply this fraction, we have equal to 1. Then we will now use the cumulative property of multiplication and change order multiplication in the denominator. So we will have the derivative of f of g of x is equal to limit as h approaches to 0 of f of g of x plus h minus f of g of x over, so we gonna change the denominator, so we will have g of x plus h minus g of x times g of x plus h minus g of x over x plus h minus x. So now g of x plus h minus gx is already the denominator of our first fraction, which is this, and x plus h minus x is the denominator of our second fraction. This would be now the product of two limits. So we will have the derivatives of f of g of x is equal to limit as h approaches to 0 of this first fraction, f of g of x plus h minus f of g of x over g of x plus h minus g of x times limit as h approaches to 0 of this second fraction. So g of x plus h minus g of x over x plus h minus x. In the second fraction, we can simplify the denominator x plus h minus x by h. So this would be equal to h, and the g of x plus h minus g of x is an input into our function f. So this is the difference of quotients of f. Therefore, the limit of the difference quotients give us f prime of g of x from the first fraction times g prime of x, the difference of g of x, which give us g prime of x. So this gonna be the derivatives of f of g of x is equal to f prime of g of x times the g prime of x. So now we're done with our proof. So for example, let's find the derivatives of 5x plus 3 raised to the power of 4. First thing to do is we're gonna move the constant 4 to the front. So we have 4, then keep the inside the same. We have 5x plus 3, and then subtract 4 minus 1, so we have 3. Then multiply the derivatives of the inside, which is 5x plus 3, so it's gonna be equal to 5. And then next steps, we now multiply 4 and 5, so we have 20, and then 5x plus 3 raised to the power of 3. So this is the final answer.